Good evening, everyone. My name is Russell Cox. I'm the CEO of Flexure Engineering, and I help convene this workshop and the several others that we have done before and we will be doing since. So I'm going to talk a lot about the different workshops we're doing and different events. Tonight, what I'm going to be talking about is the Lunar initiatives, which have grown out of the series of workshops we've been doing over the last 3 years. And I'll explain how we got to needing something more than just workshops, and how I see the future of space exploration going and the importance of lunar exploration. The objective of the Lunar initiatives is creating a marketplace for solutions for the lunar frontier. The lunar frontier, in my mind, is going to be opening in like 2020. The next 4 or 5 years is very experimental. But by the time we get to 2020, most people will have flown 2 or 3 times, and it will be much more like routine access. And so I'll explain a little bit about that as we go as well. So let me move into the beginning. The ages of lunar exploration. This all began back in 1958-59, and as one of the hot but cold fronts in the Cold War, the US and Russia did 59 missions in 15 years, ending, of course, with the manned missions and the Lunar the Russian Lunar missions, which included sample return. So we did manned missions, but the Russians actually did better rover missions. They roved very far distances, and they returned samples as well. And then we went into the dark age. 1977 to 2006, there were only 4 missions. The Japanese flew a very tentative sample mission. The ESA flew 1 mission, which was mostly a technology demonstrator, did a little bit of science, and then Lunar Prospector and Clementine went, and they were also, again, mostly technology demonstrations with a little bit of science coming out of them. It was the best science anybody did for 30 years, but by modern standards, it was marginal is a little harsh, but it was all been superseded by what happened starting in 2007. The Lunar Renaissance, kind of without anybody noticing it, began in 2007 and will extend until the end of this decade. The opening phase was in 2007. The Japanese sent Kaguya, which was a good science mission, the first real science mission the Japanese flew. Then China flew Chang'e 1. Chandrayaan-1 flew in 2008. And then the US sent an armada of spacecraft, Lunar Reconnaissance Orbiter, LCROSS, Artemis, Grail, and Laddie. And all of these missions discovered dramatically new things about the moon. Chandrayaan had an experiment called M-cubed, or MMM, for Moon Mineralogy Mapper, which discovered widespread water probably on the surface of the moon, which was a very dramatic and surprising discovery. LRO, in its first mission, the Lunar Renaissance, in my mind, really began. The revolution began on January 6, 2009, with the first light image from the Diviner instrument, which proved that the poles were very, very cold, 40 degrees above absolute zero, much, much colder than anybody had imagined, which meant there was almost certainly water ice and other kinds of exotic ices. And when LCROSS crashed into the moon, they discovered that, yes, indeed, Cabeus crater in particular was very rich in a wide variety of ices and other structures that until 2009 was all science fiction. People guessed that it might be there, but nobody was really strong enough to believe that it was there until they knew that the temperatures in the shadowed craters was below 100 Kelvin. And now we know, in fact, the lunar craters are some of the coldest places in the solar system. Down to 25 Kelvin is the coldest temperature, which is colder than Pluto. In the coming years, there's going to be as many, if not more, missions and even more capability. The Google Lunar X Prize, Moon Express, Astrobotic are going to be presenting here, but there are others who will fly. Moon Express and Astrobotic will almost certainly fly 2, maybe even 3 times. Other Google X Prize teams will fly at least once or so, even if they don't win. The Chinese are setting a pace to fly every 2 to 3 years, and they will keep flying every 2 to 3 years until they're planting a flag with a manned mission, and I think there's no doubt that's going to happen. They'll probably get 1 or 2 flights in before the end of the decade. India has Chandrayaan-2 on the books. It's still under development. The start date is iffy, but my understanding is it's well funded and it will fly, and almost certainly will fly before the end of the decade. And it has a lander, an orbiter, and a rover. Russia is relaunching the Lunar program with 5 planned missions, 4 landers and an orbiter. The USA only has 2 kind of interesting, but compared to the rest of the activity, almost small missions. Lunar Prospector, which we'll hear a lot about on Friday, and then the Space Launch System is going to include 12 lunar cubes, so in orbit around the moon for their first test flight. They're going to also launch some lunar cubes in cislunar space. Korea is building an orbiter. Japan and ESA had missions. The Japanese mission got canceled because of the earthquake and tsunami, and the ESA mission got canceled because of the financial earthquake. But they're still on the books, and they'll still almost certainly be flown. So some of these things will get delayed, some of them will fly, some of them may not, but it's not unreasonable to believe that we could have as many as 10 landers and 6 operational orbiters in lunar orbit between now and the end of the decade. That's a lot of activity. That's a lot of resources. And this phase of kind of uncoordinated, exuberant activity is what I'm referring to as the lunar renaissance, the return. And so it adds up to about 20 missions or so in 13 years. So not quite the 60s op-tempo, but a very substantial. And I don't expect it to slow down after 2020. In fact, I expect it to increase. And one of the reasons I expect it to increase is because not only, if we step back for a moment, not only have we suddenly gone back to the moon and taken measurements and discovered that it's far more interesting, far more exciting, far more relevant. There's water resources for mining fuel, so the ISRU, in situ resource utilization. There are more resources to utilize than anybody imagined, and we now know a lot more about where they are. We know that it's good terrain for scientific and engineering analogs for other missions to other places. And those other places are the cryogenic destinations throughout the solar system. Because while this was going on, more or less simultaneously, although it probably started a little earlier than 2007, but not necessarily, there's been another seismic shift in the way we think about space science, the way we think about our place in the universe. And I'm referring to that as the new cosmology. And there's a very interesting parallelism. In the first decade of the 20th century, quantum mechanics and general relativity were presented and developed. And basically, astronomy and cosmology extended those 2 theories throughout the entire universe and used the results of those 2 theories to understand stars. And from understanding stars, you could understand galaxies. And from understanding galaxies, you could understand the entire evolution of the universe. And most of that work comes out of quantum mechanics and general relativity. So before 1910, 1920, you couldn't have discovered what the universe was about, and they thought the universe was about one galaxy big. With new mathematics and new technology, they could suddenly understand the entire universe, or certainly the entire visible universe. We have recently discovered dark matter and dark energy, and nobody knows what those are, but the stuff that we can see, we understand very well. Another seismic shift has happened in the first decade of this century, and then leading up to about now. We've had a similar seismic change. Before about 2000, if you ask a knowledgeable person, how many planets do you think there are, they'd say, well, there's probably planetary systems out there, but we've never seen one yet, so they're probably fairly rare. And if we did find one, it would probably look almost exactly like ours, because the theory was there was a very structured way you build a planetary system. Now, just a few years later, with the Kepler mission and other results, we know that there are more planets than stars. We know that planetary systems are more varied than anyone ever imagined. And we know that on those planets, there are almost certainly many, many different habitable terrains. So the 21st century cosmology, the next 100 years, is going to be looking at planetary systems, planets, habitable terrains, astrobiology, and not asking the question, how big is the universe, but asking about what can we learn from everything that's close to us. We're going to study the nearest 1,000 stars very, very carefully, because there will probably be hundreds of planetary systems in those 1,000 stars, and they will be very dynamic and interesting things to explore. And why do I think that there's probably life on many, many of those planets? Well, in our own solar system, we know that on Earth, life has penetrated every habitable terrain. And in fact, again, just in the last 5, 10, 15 years, we realized that life is in a lot of terrains that people would never have imagined are habitable. We now know for a fact that there are terrains on Mars that were once habitable. So the idea that there's life on Mars is no longer science fiction. We know for a fact that conditions existed at one time, and they probably exist today. We know that on Enceladus and Europa, there are liquid water oceans that are probably not too different from the liquid water oceans under our polar caps. And so as a habitat suitable for life, almost certainly there exist habitats on the icy moons. Titan is the most bizarre example. It has a liquid water ocean, but on its surface it has liquid methane and ethane lakes, and nobody knows where they came from. And there's some evidence that maybe there's something that looks an awful lot like biological chemistry going on in the atmosphere. So I'm not quite so bold to say that there's life on Titan, but there's almost certainly life-like chemistry. And then the moon becomes the training ground. The moon is where you mine the resources to get to these destinations. If you want to send a lot of people to Mars, a lot of mass to Mars, you're going to need your rocket fuel to come from someplace other than the Earth. If you want to go back out to the deep planets and the outer solar system, you're going to want a lot of energy and preferably not launch it from the Earth. So Lunar ISRU is going to be critical to unlocking human exploration of Mars and any exploration of the outer solar system at the levels that really are necessary to discover, find the habitats, and see, is there life in those habitats? Every habitat on Earth is teeming with life. I would bet very large sums of money that the same is true throughout the solar system. And then why is that interesting? Because our solar system now, we know, is a microcosm of the universe itself. There are billions of solar systems. There are billions of habitats just like these. There are more Titans than there are Earths. And if there's life on Titan, if there's life on Europa, that's probably the life that's going to dominate the universe. And so if you want to understand the universe, if you want to understand our role in the universe, follow the habitats and find the life. And that makes everything lunar far more relevant, everything planetary science far more relevant than it has ever been before. And all of this has happened just in the last 5, 10 years. So that led me to, after doing 2 or 3 of these workshops and exploring, is that map of the new cosmology and that map of the lunar renaissance an accurate representation of what's going on? And after running these workshops for 2 or 3 years, this is Lunar Science 4. This will be our 8th event. And the resounding answer was absolutely. Everything has changed. There's a lot more activity and a lot more interest and a lot more opportunity, both in lunar space and throughout the solar system. So in order to kind of create a container for all of that activity, in order for a way to guide it and understand it and get people talking to each other about what's possible, we created the Lunar Initiatives. So the Lunar Workshops, we have 3 workshop series. Lunar Special Interest Groups, so the Lunar SIGs, are monthly meetings of people, and they're organized around the workshops. Lunar Challenges, we're going to go out and create large prize challenges, so $1 million prizes like the Google X Prize, for various activities around lunar technology. Lunar Incubators, in a few years we plan to be organizing startups and investors and groups of people trying to create a sustainable ecosystem and economics around lunar exploration activity. And then we're going to try and get created the International Lunar Geophysical Year. So 2017 and 18 is the 60th anniversary of the original International Geophysical Year, 1957 and 58, which saw the launch of Sputnik, which saw the discovery of the Van Allen belts. The 60-year anniversary, this is what kicked us all off. And now we're having a renaissance of this type of exploration and activities. So this is a bit of an eye chart. But what it is simply a calendar outlining our first workshop began in 2011. a little more than a year after I first went and met Dave Page and said, is the moon really that cold? And is it really as interesting as I think it is? So we ran the LSA, which began as the Lunar Superconductor applications, now the Lunar Science applications. But the idea is we've got annual workshops. We're now up to 3 different events. We're creating the monthly special interest groups around those events. We're going to begin looking into doing Kickstarters and the Lunar Challenges to put up cash prizes to get things built. This structure is all about making things happen. These are not academic workshops. These are interactive workshops, and the people who come to them, the people who work in the special interest groups, are all about getting things built and moving the technology and the science forward. The top 2 lines are 3 sets of events and workshops where we're partnering with them. We're partnering with Space Cryogenics of the American Cryogenics Society. We're going to move a lot of our cryogenic science to that workshop, so I'm going to try and create a cryogenic planetary science subsection in the Space Cryo workshop. The ILC, or the International Lunar Conference, Moon Express has approached us and asked if we would help organize a 300 to 500 person, more of a scientific and lunar progress conference and less of a workshop. And so that's we're still under discussion, so we don't know if that's going to happen for sure, but I think it will, and I'd certainly like to see it happen. And the notional idea is in 2015, we do a workshop in Houston that's focused on all the X Prize teams and all the work they did, whether they think they're going to fly or win or not, because even though only one team's going to win and a few teams are going to fly, there are over 20 teams that have done an enormous amount of very good science and technology planning for their Google X Prize missions. Then, as we see, the second one will be 2017. That event will kick off the International Lunar Geophysical Year. So this will be in July 2017 at the beginning of the ILGY. And hopefully we'll hold that one in Europe, and it will highlight the upcoming activities of the next 18 months. And then after the ILGY, we'll hold one hopefully in Asia, and it will focus on the results of 18 months of coordinated activity. So this is the lunar renaissance as it's going to unfold. Most of these activities, most of these missions are already funded, already under development. They're going to happen anyway. We simply created the lunar initiatives to help organize, coordinate, and promote, and hopefully accelerate both the science discovery, the engineering development, and ultimately the profitability of the companies doing the work. So underlying the lunar initiatives is not quite an initiative on its own right, but it could be. We're calling it the Lunar Switchboard. So in order to fill out that chart of all those different events, and in order to tie together the global community of planetary scientists and aerospace engineers who would like to go to the moon and beyond, we're going to create and fill out start with a grid with these 6 different groups. So there's the Google Lunar X Prize and other challenge teams, so they're national centennial challenges and other teams that would be relevant, such as a robotics team that isn't necessarily targeted to the moon, but could be very interesting technology. So we want to create a list of 20 or so prize teams. National space programs, I think there's something like 36 national space programs. We'll start with the first 10, 15, 20 that seem relevant. University programs, again, we're going to start with programs that have an active CubeSat, Lunar Cube kind of focus, but find 20 university programs from anywhere on the planet Earth that are interested in playing with us and interested in talking about CubeSats and lunar cubes. Space startups, there are a lot of large and small startups. In particular, we've already spoken with, and I intend to develop structured partnerships with MoonX, Astrobotic, Planetary Resources, and Deep Space Industries, and then a number of other much smaller startups. But those are 4 very well-funded, very focused. All of those 4 teams know that they have a 10, 20-year project. Those are the kinds of people we want to be working with and leading this movement, because it's going to take 10 to 20 years to really open up the lunar frontier, but an enormous amount of activity is already underway. Large companies and laboratories, such as the laboratories here at Kennedy, and large companies such as Boeing and Lockheed Martin and others, who have lots of resources, but are not focused on things like CubeSats and lunar cubes and small, stealthy missions to the moon. And then individual influencers, space celebrities, like Dyson and Miyaku, or astronauts, various other people who have a lot visibility, writers, journalists, and other kinds of writers who are promoting space, investors, politicians. And so for each of these 6 categories, we'll put together a list of 20 or so people that we want to start with. And then we're going to simply ask them these 3 questions. What are you doing now relative to the moon or cislunar space? What are you going to be doing in 2017-18 that would be relevant to the ILGY? And how will you participate in the lunar renaissance and the ILGY? And I think once we go to these 120 different organizations and individuals and start asking this question of them and getting their answers, compiling them, they'll go up, they'll become blog entries, and eventually we'll put a lot of the responses on the website. We will begin to really fill out the community that is organized by all these events that is leading the way back to the moon for all mankind. So now let's look at the 5 specific initiatives, and the first is the workshops. So lunar science applications, we've done 4. This is the 4th lunar science application. It's going to be focused on landers, rovers, surface missions, other kinds of relatively large missions. The Lunar Cubes workshop, we ran the 3rd Lunar Cubes workshop last October, and we'll be running, October, and we'll be running the next one this October. And then we have the new event called Opportunities in Cislunar Space, which goes back to that chart of even if where you really want to go is Titan or Enceladus, there are analog environments on the moon where you can test your 100 Kelvin, 50 Kelvin technology in deep space, in scientifically and technically relevant environments. So the Opportunities in Cislunar Space workshops are going to be about developing the forward-thinking science. What is the science objectives that we're going to be building missions to achieve 10 years from now, 15 years from now? So that's the farthest out looking one is the stocks workshops. The lunar science applications is again going to be focusing on the fairly large missions that will fly every 2 or 3 years, every 5 years or so. Astrobotic can probably sustain a cadence of every 3 or 4 years. Different kinds of that, but taken together, there will probably be a lander or 2 a year in the next 5-10 years. So those are the workshops, and they're very interactive. They're very forward-thinking. They're about getting things done. They're not about progress reports on last year's activities. And to really enhance that, we're also going to organize the special interest groups. Since January, we've started with 4, and they've each met a few times by now, and we're going to try and set up a cadence where they meet monthly. Eventually we'll want, say, 2 to 4 different special interest groups for each of the workshops. So if you attend a workshop, you can pick a sub-discipline. So in Lunar Cubes, maybe you're focused on software, or maybe you're focused on the electronics, or maybe you're focused on Lunar Cubes missions. And eventually, a year or 2 from now, there will be a special interest group for each of those sub-disciplines as well. And so that again will be groups of 10, 20 people who meet on a regular basis talking about what are they building, what are they flying, where are they planning to go, how are they planning to make it happen. The lunar challenges, probably starting sometime next year, we'll begin organizing these, and the idea is to have at least 1 challenge per workshop series, and down the road maybe as many as 2. So I'll talk about this on the Thursday presentation. What are the types of challenges we've already got in the books and outlined. But we can both raise our own prize money as well as work with people like the X Prize Foundation and NASA Centennial Challenges. We'll be submitting our proposals to both of those organizations, as well as we have the opportunity to essentially kickstart or raise our own. Lunar incubators, again, probably starting the organization in another 2 to 3 years, but already we're talking to a variety of incubators in the Bay Area and Sacramento in particular. And so looking for companies in the areas of lunar cube-based technologies and companies. Lunar access, this is about building things like CubeSat carriers, secondary stages, other various ways of getting to the moon. So Astrobotic and Moon Express would be large, already formed companies that are examples of things that might show up in the Lunar Access Incubator. And then the lunar networks is a variety of networks: communication, power, computer services, navigation networks. So there are a variety of startup concepts of both services and hardware that could be built, and that would be focused in the Lunar Networks Incubator. So these are all, again, some early stage ideas, We know of several examples in each category that could be a place to start, but the initial goal is to build out the community of people and attract a wide array of investors who might invest before we bother bringing in the companies. You don't want to bring in the companies until you already have an audience of folks who want to know what they're up to and might just invest. So the incubator initiative is one of the more longer term ones, but it's also one of the more important ones, because again the goal is not just to go back to the moon 20 times or even 60 times and then stop. The goal is to create a sustainable, continuous set of access and science and engineering in cislunar space. So the fifth initiative is the International Lunar Geophysical Year. As I mentioned, the original IGY, International Geophysical Year, was in 1957 to 58, and there were three major themes and outcomes of the IGY. The first was Sputnik and Van Allen proved that you can go to space. Suddenly the space race was launched because of a handful of successful rocket missions that were initially purely scientific in origin. The Antarctic Treaty System came out of the IGY because most of the activity was in Antarctica, and it focused on the poles and the upper atmosphere. So the Antarctic Treaty created, in the heart of the Cold War, peaceful scientific settlement of Antarctica. We're going to need something very much like that in the moon very soon. If we've got 10 landers on the moon 5 years from now from 5, 6, 10 different countries, they're going to need to get organized. We're going to need to revisit how we do the Moon Treaty and how we do collaborative work in space. So the peaceful scientific use is what came out of the IGY, is the scientists got together, drafted the bulk of the Antarctic Treaty System, and then the politicians and diplomats came in and made it real. It was backed largely by the U.S. military, but they left all their guns home. So one of the things that came in the IGY was permanent settlement of the South Pole and the pledge that no one on the South Pole should have weapon systems. And because of that, no one ever took major military action in Antarctica. We would like to see something similar happen. So coming out of the IGY, it's not going to happen during that 18-month period, but coming out of it, we want to create an environment of collaborative mutual exploration, create some sort of 21st century legal framework, diplomatic framework that establishes peaceful scientific exploration and resource utilization that is for the benefit of all mankind, for the benefit of the global community down here on the ground.